For these examples, we're going to want to get rid of the brackets first and then get a common denominator in order to solve our equations. So for example C, we have a numerator that has two terms over a denominator, a single denominator, so we know we can separate that into two separate fractions. So we're going to get 2x over 2 minus 3 over 2. That's going to be equal to negative x over 4 minus 1 over 4. This time our common denominator is going to be 4, so I'm only going to have to change one side of my equation. The right-hand side of my equation can stay like it is. 2 goes into 4 two times, so 2x times 2 is 4x. 2 goes into 4 twice, and 3 times 2 is 6. My denominators can cancel, and my equation becomes 4x minus 6 equals negative x minus 1. Let me get the x's on the left-hand side, so I'm going to add x to both sides to make that a zero pair. 5x minus 6 equals negative 1. I'm going to add 6 to both sides to make that a zero pair. 5x is going to be equal to 5. Divide both sides by 5 to cancel that, and x is going to be equal to 1. For the next equation, for example D, we're going to have to use the distributive property. So 1/2 times x is x over 2. You can put down 1x over 2 if you want, that's fine. 1/2 times negative 1 is negative 1/2. 2 over 3 times 1 is 2 over 3. And 2 over 3 times x is 2x over 3. Now that I have that, my common denominator is going to be 6. So I'm going to change all the fractions to a denominator of 6. 2 goes into 6 3 times, so 3 times x is 3x. 2 goes into 6 3 times, and 3 times 1 is 3. 3 goes into 6 twice, so 2 times 2 is 4. And 2x times 2 is 4x. Now I can get rid of my denominators because they're all the same, and my equation is 3x minus 3 equals 4 minus 4x. Let me get rid of this negative 3 first, so I'm going to add 3 to both sides to cancel that. I get 3x equals 7 minus 4x. Then I'm going to add 4x to both sides to make that a zero pair, and 7x equals 7. The inverse of multiplying by 7 is dividing by 7, so x is equal to 7 over 7, which is equal to 1.